Hello everyone, welcome to day 3 of Avalon. Today we're finally gonna talk about some more technical stuff, but unfortunately today is still gonna be a document heavy day. As I have mentioned in the previous 2 days, all the prep work is vital so that we are fixing the problem using the same tool, heading to the right direction. So bear with me and let's get started. Let's recap what we have done yesterday. Yesterday, we have we have talked about the input and the output from the users, and I came up with some wireframe and all the actions and information the players have, and I have updated all those wireframes in the design doc, and I have pushed it to GitHub, so feel free to check it out. And today, with the front end or client side figured out, we can finally think about how can we fulfill those requirements. So, before we get started, I know, well, if some of you have some knowledge about web application development, you must have heard of RESTful API. It is basically the the mostly used architectural style for network application. And by the way, REST stands for Representational State Transfer. And some of the characteristics are they are stateless, they are resource based, and they are the actions are described by the network verbs. I highly recommend you to take a deep look at the terms because it is often asked in the technical interviews. And speaking of technical interviews, even though the RESTful API is practically the industry standard, it is always a good practice to consider and compare other options just to keep ourselves honest. And it is also show your knowledge depth and that you are a professional during technical interviews. Okay, so speaking of backend, according to the front-end design, I have listed the following functionalities the backend must support. So let's think about it from the very beginning. So the game admin creates a game, and the admin starts the game with the configuration. Each player joins the game. Once everybody is joined and admin started the game, the server will have to broadcast to everybody that the game has started. And once the game started, of course, the first mission starts, and it is also gets broadcasted. And once a mission started, of course, a round by default starts, and it will also be broadcasted to everyone. And once a round has started, there must be a leader. It is highly likely to be randomly picked. The leader, the backend will have to notify each player that before even that, the backend will have to notify each player their role and their known players. And then the backend will notify the current leader to submit a team proposal while broadcast to everybody that the game is pending for the current leader to submit a proposal. And the team leader should be able to submit a proposal to the backend, and once the backend receives it, it will broadcast this proposal. Um, it will have to broadcast this proposal to everyone. Once this is broadcasted, the backend will basically broadcast every all the players to start to vote for the proposal, and the players will have to be able to submit a vote for that proposal to the backend. And once all the players, so once a player has voted, the backend will broadcast that that particular player has voted, and everybody receives it, then knows who has voted and who has not. And once the backend receives the last vote, it will calculate the round result and broadcast it. And if it fails, then we in turn, the next person becomes the leader, and we go back to the leader notifying the current leader to all the players and notify the team leader to submit a proposal. But if the proposal is agreed upon, is passed, basically voted for by a majority of the players, now the backend will have to notify each team member to vote for that mission, and broadcast to everybody that the game is pending for these team members to vote for a mission. And once a player voted for a mission, the backend will broadcast this event to everybody, so that all the players know who has voted and who has not. And once the backend receives the last vote for that particular mission, the backend then will calculate the results and broadcast to everybody the result. And then, of course, afterwards, we automatically go back to start a new mission, then automatically start a new round, then select a new, to basically get to set the next leader. And if this is the last mission, so 3 out of 5 either being succeeded or failed, the backend will have to calculate. So if it's already 3 missions failed, the backend of course will broadcast the result automatically with everybody's role. But if it is 3 passed, and the evil team gets an assassination opportunity, then the backend will notify everybody that we are pending for the assassin to pick a target. And once the assassin will have to be able to submit a target to the backend, and the backend will have to broadcast that the assassin has picked this particular target, and tell everybody if this is the role of that particular person. And once that is done, the backend will have to broadcast the game result, whether the good team or the evil team has won. So this is a typical state machine, and we can come up with a state machine diagram, as you can see here, so each state receives an event And after receiving that particular event, the game the state itself will have to be able to decide if they proceed on the next state or keep at the current state. Um, so this diagram is rendered on a mermaid. So you can just simply copy this source code and paste it on mermaid and see the results there. So once this, with that being said, we also then we want to compare the backend architecture. This is a vital part of the project because it determines how the subsequent design will be made. So I honestly, like I mentioned in the beginning, many people just go directly to RESTful API when designing a backend. Even though it is theoretically true in real life, but during technical interviews, it is highly recommended that we know other options and their pros and cons and be able to compare different options for this particular use case to show the interviewer that our breadth of knowledge, which is often some, I think, people new to the industry miss. We it's actually, with all the interviews I have done myself, well, I have been on both sides. I have been interviewed and I have interviewed people. It is always a red flag when the candidates just goes directly into just the one option and dive deep into that without considering other options, even though that option is clearly the optimist solution, the optimal solution, but it just gives a very bad impression to the interviewers that this candidate might got lucky. Maybe the only approach the candidate knows happens to be the optimal solution for this use case. It is vital, I cannot stress this enough, that I encourage everybody to really think about different options when you go into the design, even though these options just seems just seems obscure. Still, list them out, write it down how weird or not suitable for this project so that we could start to have a discussion and see maybe what we have left. Okay, and today I will spend much time on the different backend architectures. So first of all, so for our case, I think the best approach is the mix of WebSocket and RESTful. The reason is that if we really think about our use case, and I have mentioned in the technical consideration yesterday that the communication between the user and the system is bidirectional. So not only the player has to be able to submit information or events to the backend, but also the backend has to be able to um, communicate with the player. So it's basically push data to the player in real time to notify them what has happened and ask them to perform an action. For example, voting for a team proposal. So all the with all the options we have, WebSocket is basically the most suitable one because it is real-time communication. It is definitely bi-directional. It is supported by many frameworks and cloud service providers. Even though it might lose connection, it is a little bit complicated to implement. But other than that, the alternatives are simply too complicated or not suitable, not as nice as WebSocket. So that's why I propose WebSocket. We also consider the RESTful API. It is simple, it is stateless, it is wide adopted. And I want to take a pause here and say why stateless is so important. I think back in the early 2000s, back then I think even now, but especially back then, the first thing we implement for web application is the session. A session contains all the user states and store that in a connection. After like 20 something years, we could never get rid of state because state is a vital part of all the applications. Like, for example, in this game, the game can be in a state where it is pending actions from every player or just pending for this one player to vote or this the current leader to pick a team. So the states never went away, but managing state is much more complicated than it sounds. So think about it. If we maintain a state in one connection, what if I'm connected to the backend via 3 devices on my phone, on my laptop, and on my tablet? Then if the state of one device, like let's say for example we change some state from one device, then how do we let the other device know? And if the state is not backward compatible, there could also be conflicts. There could be all sorts of problems. It's just such a big mess to even start talking about. And what does stateless? So stateless doesn't really get rid of state. It just goes. It's just a very simple and elegant solution to this very complicated problem. It just saves this state. It just maintains a single source of truth. For example, now this game can have many states, and we have up to 10 or 11 players of this game. Instead of maintaining this state in these 11 connections, we just keep the state in the database in a single place, which can only be changed one at a time. In this case, no matter how many parallel requests uh, coming in, we always just process one event at a time and change the state accordingly. And once the state is changed, we can validate the incoming events or incoming requests with the current state so that we don't, in this case, we have like one single source of truth so that we are not worried about the parallelization or in, um, invalid requests. So if a request is made and we realize that this request is not compatible with the current state, we could just always handle this problem with fetching the latest state and change our request or deal with that the, on the client side. It's it is very elegant. It is very simple, and that's why it is practically the industry standard. But even with that being said, I just want to remind everybody that don't just go directly into there. It is a great approach, but it's never the only approach. Okay, let's continue. So RESTful API is simple, it's stateless, it's widely adopted, but it does not have bi-directional communication. So remember I've mentioned that it has one single source of truth. RESTful API is just resources there pending to be fetched or modified or updated. So if we want, there's it's very hard to have real-time communication from RESTful API. The only approach might be just polling the backend very frequently. It's a waste of resource and simply does not make much sense unless especially in this case, because we do need real-time communication. We don't want everybody, like nine people, to wait for like one person to be polling the next time. It is possible, but it is not recommended. There's GraphQL, of course, but it supports very flexible queries, very complete queries. It only has one single endpoint, which is easy to implement, and we have all the libraries and frameworks just to have GraphQL in a snap of finger. But the thing is, this is a little bit overly complicated for the use case. We just need to send and receive a couple of standardized events between the backend and the player. So if we have a complicated system, maybe maybe a real commercial use case, maybe this makes some sense. But for our use case, it's definitely an overkill. There's gRPC. If you haven't heard about it, it's a protocol mainly designed for communication between services. It is ideal for service-to-service communication. It is very high performance. It's bi-directional communication, but it's definitely limited in supporting browsers, and again, this one's overly complicated for our use case. And here we have the good old SOAP, which is XML based. It is very strict. It has built-in handling. Back in the old enterprise Java times, SOAP was a standard. Um, but nowadays, REST is almost better than this in every single way. Um, I myself haven't came across with any project that SOAP is the optimal solution. But it's always good to know that there is this thing there and it could be considered. And the last but not least, we have JSON RPC and XML RPC. RPC is basically a remote procedure call. It's basically calling a method through the internet or through the network. Um, if you read about it, it's the opinion about this are very it's not unified. On the one hand, it definitely can uh, simplify lots of logic. We are calling a service just like a function call in our code base, but then because this call is being done on top of a network, and there are many things could happen when making a transfer through the network. So the error handling is much more complicated than one person might imagine. And the thing is, function call and network API call are fundamentally different is in a way that the function call we never expected to fail, uh, but requests request sent via network, we by default assume it could fail. So with these, you'll have some very weird coding style, and just I myself don't think this is a good idea, at least for our particular use case. Okay, so with all that being said, I think our project will be a combination of WebSocket and RESTful API. The RESTful API will be used for the actual resource management. For example, creating a game, saving a game, requesting all the event from requesting all the events from the game, because again we have to consider the loss of connection, the crash of browser. So any player should be able to start should be able to start the game at any given time, and easily get the latest state of the game. And for the WebSocket, we use that for real-time communication. For example, so once the user has the latest event of everything, the server will then communicate with the player using WebSocket at real time. Okay, I think today we'll wrap up here. Tomorrow, so with the state machine and architecture decided, I think tomorrow I'll start designing the backend and think about the implementation of the state machine. Yeah, so I think a couple of things to recap here is that recap. So, I think this is the only thing I want to mention. They always propose multiple approaches when dealing with a project, dealing with an issue. Even though there is a clearly optimal solution and others are simply clear solution. It is always nice to have alternatives listed next to the recommended solution, and by doing this, the reviewers would know why the recommended solution is the optimal, is the best one. Plus, during technical interviews, it shows the breadth of your knowledge. Okay. Yeah. Cool. I think it's precisely 30 minutes. It's I think a good amount of time for me. I don't cramp up too much information in one session. I know we're going a little bit slow and we're not touching any code yet, but seriously, I think knowing how how a software engineer thinks and their approach to a problem is actually more important than learning a programming language, which you can basically, there are millions of free resources, but I definitely see very few videos to have a detailed explanation of the approaches, like the approaches real life software engineers do their work in real life, and even less to explain why do we do all these things. So I hope this could be helpful to you, and keeping this in mind, I truly believe this would help you during technical interviews. Okay, thank you for watching. See you.